welcome to the MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today, we will be studying a very interesting module from applied mathematics, that is first order and first degree differential equation, which includes topic solution of differential equation, where we will be studying some interesting fact about solution of differential equation, and we will be practicing some of the example based on it. So let us begin. My dear students, welcome to this session of our subject Applied Mathematics M2. Module is differential equation and topic is solution of differential equation. Learning objectives. Objective is, at the end of this unit, you should be able to know the technique to solve the various types of differential equation. Learning outcome. Learning outcome is, one should be able to recognize and solve variable separable differential equation, and second is, one should be able to recognize and solve linear differential equation. Introduction. First order and first degree differential equation. Types of differential equations are variable separable differential equation. In short, we can say VSDE. Linear differential equation, we can shortly say LDE. Now, first type of equation is variable separable differential equation. Any equation of the form dy by dx equals to f of x upon f of y is a variable separable differential equation, and solution of such equation is given by separating x and y and integrating both sides by adding constants of integration on either side, and that equation is f of y dy equals to then f of x dx. Keep in mind, dear students, here in this expression there is only two terms, and that is f of y dy into equals to then f of x dx. When we are going to say here, this is a variable separable equation containing two terms, and hence we come to that is, we are going to say variable are separable in this equation, and then we can say, we can integrate that one as f of y dy equals to then f of x dx plus c. And here we are going to give that constant of integration plus c on either side. We can say that is here plus c, we can take on this side also. Example, first example is now, solve x dy by dx minus y equals to 0 now. So, see here, there is x dy by dx minus y equals to 0, and this is definitely variable separable equation containing only two terms. One term is x dy by dx and another term is y. Solution for this one. So we can write that equation again here, x dy by dx minus y equals to 0. So we can transfer this y from left to right, and that is, we can say here minus y we can transfer from that left hand side to right hand side, and which is take positive here, and student make the mistakes here for transferring that minus y. Multiply dx on both sides, so we can get that term x dy equals to then y dx. But now again here, this x is not a coefficient of dy and y is not a coefficient of dx. Therefore, we can say that is dividing by xy, because we don't want that x and y in that particular term, and hence we can say that is we can divide on both sides. So, division of this particular one is specifically right at x upon xy dy equals to y upon xy dx. Now, from this upper term, again that x get cancelled, so remaining term is dy upon y, and here y upon xy dx are the dx upon x. Now here there is no x in dy upon y, there is no y in dx upon x, and hence we come to that conclusion here as definitely we can take that is as the variable separable equation here. And now next step we can say on integrating we get dy upon y equals to then dx upon x. Now here student must know the formula for this dx upon x, because one of the standard form on the right hand side here they are, and hence on the basis of the dx upon x we can write on left hand side first as log y equals to log x plus log c, and here why we take that plus log c. Reason for that one is when both the terms are logarithmic terms, constant of integration should be chosen as log c so as to write answer in compact form, and that answer is log y equals to then log cx. And now we can apply one of the laws of logarithm from this one as a log mn, as we can say right log cx. Therefore, on both sides log get cancelled, so answer is y equals to cx. Can anybody guess that answer? C answer y equals to cx. Second example is solve sec square y tan x dy minus sec square x tan y dx equals to 0. Again we can take solution for this one. Sec square y tan x dy equals to then sec square x tan y dx. Now here this is definitely variable separable equation, but variable are not separable here, because in the dy there is a term of tan x and in dx there is a term of tan y, and we don't want a term in that particular expression, and hence we can say that one is dividing by tan x tan y both sides. After dividing that one, so we can remove that tan x from this dy, see here, and we can remove that tan y from this right hand side term, see here sec square x upon tan x dx. Now here we can say that one is variable or separable. In that expression there is no expression on left hand side, no term of dx. On right hand side expression, no term of dy. On integrating then we get sec square y tan y dy equals to the integral of sec square x upon tan x dx. Since x and y are given separated, given equation is variable separable. As I told earlier, there is no y on the right hand side, there is no x on left hand side, and hence we can say integration of this one is log tan x equals to then log tan x plus log c. Here we use one of the method of integration for solving the differential equation, and as you know that one is already in your substitution for integration. It contains using this form. See here that form is focus on this particular form as a f dash x upon f of x dx equals to log f of x, and we can say that term is the tan y, we can say sec square y into the dx. So we can say integration for this one is log tan y equals to then log tan x into c. Again we are going to apply the laws of logarithm here also, and we can get that its log get cancelled from this expression. Tan y equals to c tan x. Can you guess the answer? See, that answer is here. Tan y equals to then c tan x. So we can interpret this in any way, but we can write this one as the tan y equals to c tan x. Third example is solve dy by dx equals to minus root of 1 minus y square upon 1 minus x square. Now in this example our focus is that minus sign. Always most of the students make the mistakes for this minus sign. Solution for this one, we can write as it is expression again. So here see, question is given and term we are going to write. How I can write that particular one? We can apply here this formula for writing that term, because it is a very simple formula. Root of n upon ab, that is equals to then nth root of a upon nth root of b. Separate that root here, and now we can take next step. This implies dy upon root of 1 minus y square equals to then minus dx upon root of 1 minus x square. Here we are going to take, we can separate directly, because you know that what is, if we take dx on that side and we can write that root of 1 minus y square, there is no x in this one, there is no y in that right hand side term. So now here we can say this is a separable variable. Once we are going to separate that variable, next point is integration. So we can say that one is on integration of this particular expression as the dy upon root of 1 minus y square plus dx upon root of 1 minus x square 0. And again we come to that is one of the standard form here, which is given in your topic of integration. That is one of the standard form here. That one is, we can say dx upon root of 1 minus y square as a sine inverse y, dx upon root of 1 minus x square as a sine inverse x, that equals to then c. So this is that standard form as we apply earlier. See here. Here we can take the value of a square specifically in that particular formula 1 in both the cases, and hence we are written here sine inverse y plus sine inverse x equals to c. Have you guessed the answer? Yes, see that answer is sine inverse y plus sine inverse x equals to then c. Now next type of equation is linear differential equation. In short we can say LDE. What is that equation? An equation of the form dy by dx plus py equals to q is a linear differential equation where p and q are functions of x, or we can say constants. To find solution, we need to find integrating factor. For that integrating factor, we can say in short, not fully, if, where if is e raised to integral p dx. The solution, finally we can say, we come to that, what is that solution of that differential equation? Writing by y into if equals to then integral of q into if dx plus c. We are going to insert that if in this particular solution. Now first example in that linear differential equation is solve dy by dx minus y by x equals to then x cube. Solution for this one. Now we can compare that given differential equation with the main equation as dy by dx plus py equals to q, and hence we write here as a comparing the given equation with standard form, because this dy by dx plus py equals to q is a standard form to solve any types of linear differential equation. So here by comparing that one, if we compare these two equations, see that dy by dx here plus sign is here y, and hence we can say the coefficient of y is p equals to, we can say, minus 1 by x, and the value of q on the right hand side, see here right hand side is x cube. So this is the first point, we obtained that p and q. Then we come to that is if at the e raised to p dx. Now that equals to, then we are going to put the value of p here by using that minus 1 by x dx. Then we come to that is integrating factor is x raised to minus 1 equals to 1 by x. Since now here we can take that is e raised to log m equals to m. So final solution is y into then 1 by x equals to then integral of x cube into 1 by x dx plus c. Now here we can write that one, we can insert that y inside x cube, we can delete one x from that one. So we can get one of the standard form here, x square dx plus c. So finally we come to that is here x cube by 3 plus c. Because this is again one of the standard form, because students must know each and every standard form which is given in the topic of integration. So can anybody guess the answer of this example? See that example, answer is y by x equals to then x cube by 3 plus c. Again always we can say c is a constant. Next example, solve dy by dx minus tan x into y equals to then sec cube x. Solution for this equation is, again we can compare the given equation with the standard form, and that standard form is, again we can write here as dy by dx plus py equals to q. Simply when we compare, you keep in focus for that p and q, not the dy by dx and y already in your original equation, and that is the equation you want to solve, that is given as it is. And hence we can say here again, see that this is a standard form, this is the equation parallelly containing same term. So by comparing this one, we come to here at the p equals to minus tan x, by this is plus p, that is a minus tan x, this is the coefficient of y, and the value of q on the right hand side as a sec cube x. So integrating factor, next point is integrating factor, we can say e raised to integral p dx, this is a standard form for finding integrating factor, and simply here we want to put the value of p is minus tan x dx. So we can take then that is next step. So log sec x, again this is one of the standard form, tan x dx. The integral of tan x dx is log sec x dx. See here, integral of tan x is minus log sec x dx, and if we simplify that one again further, we can get that equals to then e raised to log sec x raised to minus 1. Now here we are going to apply this law. Since n log m equals to log m raised to n, then again we come to that e raised to log m equals to then m, and your answer is sec x raised to minus 1. We convert that as 1 by sec x. Again we can make that, student can make more mistake here, that we can write 1 by sec x, and now that 1 by sec x is one of the standard form in that your trigonometry, that is 1 by cos x is sec x, then 1 by sec x equals to cos x. Solution is given by, again this step we can go to repeated y into if equals to then q if dx plus c. Why we repeated that step again and again? So that student can mug up that formula again and again, what we write the solution for that one. So we can say that one here y cos x, because the integrating factor is our cos x, which is given here, and then we can say that is integral of sec square x into cos x dx plus c. So now here we can simplify this expression, because again we bring it that expression, because symbol is integration, means you want to find out integration again here, and that is a big point of the student always. So by taking here, see we can cancel that one. How we can cancel? here as sec x cos x. So by using the trigonometry, sec x cos x equals to 1. It is given already, and hence we can write this one as sec square x dx. So answer is y cos x equals to then tan x plus c. So your answer is y cos x equals to then tan x plus c. Next example again. Solve dy by dx plus y equals to then e raised to minus x into cos x. Solution for this one again. We write that equation here. Again we come to that is, there is a standard form. We repeat it again and again, that one in each problem. Dy by dx plus py equals to q. So we can say the value of p is 1 because coefficient of y is 1 here. See here y equals to 1 and q equals to, that is the right hand side of that equation as the e raised to minus x into the cos x. Integrating factor, this is the standard formula again, e raised to p dx. Simply we can put the value of p there, and this is c here. The value of p is 1. We can say 1 into dx as a dx there. That integral dx, again this is a standard formula, and that integral of dx is x, and hence the integrating factor for that particular expression is e raised to x then. Hence general solution is y into integrating factor integral of q into I of dx plus c. Now here we want to put the value of I of which is obtained in the above step, that is e raised to x. So next step is, we can say that is y e raised to x, then this is your q inside bracket, e raised to minus x into cos x, that is your q, and integrating factor is e raised to x, and now dx plus c. We want to simplify this one and bring it again in the standard form. Hence general solution is, see that y into I of equals to q I of dx plus c. Here cos x e raised to minus x e raised to x dx plus c. E raised to 0 is here. Again you are going to use one of the law of indices in this e raised to minus x into e raised to x there, and the value of e raised to 0 is 1. So we can get that is by using this formula. See here that formula, law of indices is given for this e raised to minus x into x. How we can write e raised to 0 here. So next step we can get, that is integral cos x dx plus c. This is again one of the standard form which is given in integration. So value of this one is y e raised to x equals to then sin x plus c. Yes, my dear students, can you guess the answer for this one? Answer is, we can say y e raised to x equals to sin x plus c. You can interpret that answer in terms of y also. Keep in mind that one. Recap with objectives. At the end of this unit, you should be able to know the technique to solve various types of differential equation. Conclusion is, at the end of this unit, differential equation, you should be able to know the types of differential equation. It is recognition, formation, solution, and general application pertaining to the engineering field. Yes, my dear students, do you have any question?
Yes, sir, I have. Is the following differential equation is variable separable: cos x dy by dx plus y is equal to log x?
Yes, see. This is one of the differential equation, cos x dy by dx plus y equals to log x. And your question is, the differential equation is variable separable. No, because the equation containing three terms and differential equation containing only two terms. Are you followed? or are you satisfied?
Yes, sir. Thank you.
Yes, my dear students, do you have any question?
Yes, sir. I have.
Ah.
Is the following differential equation is variable separable cos x dy by dx plus y is equal to log x.
Yes, see, this is one of the differential equation cos x dy by dx plus y equals to log x, and your question is, the differential equation is variable separable. No, because the equation containing three terms and differential equation containing only two terms. Are you followed, or are you satisfied?
Yes, sir. Thank you.
Now you are fully competent to solve the problem of differential equation. So worksheet is given below and try to solve it. Now solution of worksheet is provided for cross verification. First equation dy by dx equals to e raised to x minus y. Here we are going to use only that formula as e raised to x into e raised to minus y. Law of indices only, and student make that mistakes here. Now multiply by dx, and we come to that step here again by multiplying e raised to y, that e raised to y get cancelled, come to that variable separable equation, and answer is e raised to y dy equals to e raised to x dx plus c. Because both are standard form, we can say, we can convert it. The value of p is cot x, and again here minus sign, keep in mind that minus sign, do not make that mistakes here. So by taking the value of p equals to cot x. Next example is easy, dy by dx minus y cot x equals to then cos x. Solution for this one is, as it is dy by dx we can write, so we compare that one, we can find p and q, again we can find integrating factor there. Then integrating factor we can say here as e raised to cot x, again we are going to use that formula, and here we are going to use one of the properties of logarithm. E raised to log x is always x, and hence we can write this one as a sin x. Hence general solution is y sin x equals to integral of cos x sin x dx plus c, and integral of sin x we can rearrange that term so that we can say, that is, we can put some substitution here. So now here we can put sin x equals to t, cos x dx equals to dt. Note it here, see that, because without converting that expression in the standard form, we can go further, and by putting this value sin x equals to t, cos x dx dt, we can get one of the standard form t dt plus c. So integral for this one t by using one of the formula, then again as a t square by 2 plus c, and again substitute that sin x here. So your answer is y sin x equals to then sin x whole square by 2 plus upon 2 plus c. Now example is a moderate one. So example is dy by dx equals to xy plus x plus y plus 1. Solution for this one is, we can say that is, this is the expression, we can mold this equation as the x into y plus 1 by taking first two terms together and that last two terms in another bracket, and again common is y plus 1 here, x plus 1. So next step we can get dy by dx equals to y plus 1 into x plus 1. Now our aim is variable separable, for that one we can multiply by dx, so that from left dx get cancelled, see here. So what is the term is there, y plus 1 into x plus 1 dx. Now dy equals to y plus 1 into x plus 1 dx, but this is not a variable separable equation, because our aim is variable must be separable, and here variable are not separable, and hence we can say divide by y plus 1. Now on left hand side we can get dy upon y plus 1, and by dividing that one, that term get cancelled, so that is x plus 1 dx. Now we can say variable are separable here, and hence we can say on integrating that particular one by using that rule and other formulae. So log of y plus 1 equals to then x dx plus integral dx then. Now here my focus is here, this is not one of the standard formula, but student can make a lot of mistake. Here the value of a is 1 and in place of a is b. So that we can use this formula as a log of x plus a, means that value of x is y there and value of a is 1, and this is always student make a mistake to apply that formula is integration, note it that one, and hence we can say log of y plus 1 equals to integral x dx plus dx. Now x dx as x square by 2, integral dx is x, and once we complete that integration, insert that constant of integration. Keep in mind that constant of integration must be necessary, and your answer is log of y plus 1 equals to then x square by 2 plus x plus c. Now next moderate example is cos square x dy by dx plus y equals to then cos x. Again here we are going to solve this equation, but our linear equation says there must be a coefficient of dy by dx is 1, here coefficient of dy by dx is cos square x, and hence we can say by dividing that equation by cos square x throughout, we say here dividing both sides of the equation by cos square x, so we can get that term is here, so that dy by dx, then 1 by cos square is 6 square xy, and on that side tan x into then 1 by cos square x. So dy by dx plus 6 square xy equals to then tan x 6 square x. So by comparing that equation again we can get p and q. So next step is integrating factor. Second point in that linear differential equation is to must find integrating factor, and that integrating factor we can put the value of p as a 6 square x, and this is again one of the standard form e raised to tan x there. We can get integral of 6 square x dx as the tan x. Hence general solution is y into if equals integral of q if dx plus c, and that we put that here integrating factor whatever given here, then again integral of tan x, that is the value of q is given previously, and integral of e raised to tan x is there, so that we can rearrange that term in a similar way, so that in future we can apply some method here also again. By substituting tan x equals to t, again my focus is one of the substitution method here. We are going to apply by substitution method for applying that particular differential equation, and here we are going to say tan x equals to t sec square x dx as the dt, and student must forget all these things. Then we come to that is by using that tan x equals to t here and sec square x dx dt, we come to that on the right hand side as the integral is t e raised to t dt. Then again t raised to t, we can apply another method, and that is called integration by parts rule, because we convert that first substitution method, then come to that is integration by parts, and that integration by parts says first function integral of second minus integral of d by dt of t is 1 here, and integral of e raised to t dt plus c, that is equals to then again t raised to t minus e raised to t plus c, and plus we can say that is common take, we can take the e raised to t here, t minus 1 minus c plus c. So e raised to t minus 1 plus c, y raised to tan x as a your answer then, and finally we can write this one as answer, your is y e raised to tan x and equals to then e raised to tan x into then tan x minus 1 plus c. We can mold this expression again in another way also, but don't go further. Why? Because there is some confusion in your mind how we can write that particular e raised to tan x on right hand side, and there makes a lot of mistakes again. So next typical example is solve 1 plus x square dy minus x square y dx equals to 0. Solution for this one is, now again we come to recognize that one is where this is a linear or variable separable. Two terms are here, means definitely this equation is a variable separable. We see here only two terms are there, and hence we can say how we can separate variable separable by using that dividing 1 plus x square and y, so that we can get 1 plus x square upon 1 plus x square upon into y dy minus x square y upon 1 plus x square dx equals to 0. So once that get cancelled, we can get that is integral 1 by y dy minus integral of x square upon 1 plus x square dx equals to 0. So simplify that one, so this is we can get log y minus, now here our focus is here, because here again some evaluation of integral, means that is your previous topic. So how we can make standard form, that is a base, and students are lagging behind to solve this particular integration here. So by using that one, we can write here that step now. One plus x square upon 1 plus x square minus 1 upon 1 plus x square dx, and focus is on this term. See here, because we are going to write this one as the 1 plus x square upon 1 plus x square, means that is 1, and by using that rule, this is 1 and this dx we are going to connect here, so that formula is dx minus 1 upon 1 plus x square dx as it is there, and hence we can say that is minus inside bracket x minus tan inverse x equals to c. Finally we can get log y minus x minus tan inverse x equals to then c. Your final answer now here is log y minus x plus tan inverse x equals to c. Again next typical example, 1 plus x square dy by dx plus y equals to then e raised to tan inverse x. Again here in this expression, so our aim is when we solve linear differential equation, coefficient must be 1, here 1 plus x square, and hence we can say we can divide this by 1 plus x square. So dy by dx plus 1 upon 1 plus x square y equals to e raised to tan inverse x into 1 upon 1 plus x square. So now we can say here at this stage, we can identify here that is a linear differential equation. We are going to identify at the initial stage, but your form is dy by dx plus py equals to q, hence we come to that conclusion, definitely this is a linear differential equation, and then we can apply further process as we can compare this with of the form dy by dx plus py equals to q, where we can get the value of p is 1 upon 1 plus x square, q equals to e raised to tan inverse x into then 1 upon 1 plus x square. Integrating factor we can say always if we can say the e raised to p dx equals to then e raised to integral of 1 upon 1 plus x square dx. Then again we are going to use that formula e raised to tan inverse x, since this is our standard formula again here. Hence general solution is y into if equals to then integral of q if dx plus c. We can write this one that the e raised to tan inverse x of e raised to tan inverse x into 1 upon 1 plus x square dx plus c. Focus is again our bracket term. So now substitute e raised to tan inverse x is equals to t, so that e raised to tan inverse x into 1 upon 1 plus x square dx is a dt, and hence we can say integral is only t here, t raised to 1 as the t square by 2 plus t. Here we are going to apply that formula which is written here, and finally we can say y e raised to tan inverse x equals to then e raised to tan inverse x whole square by 2 plus c. Your answer is y e raised to tan inverse x equals to then e raised to tan inverse x whole square by 2 plus c. Recommended next topic, module is differential equation, Topic is application of differential equation. Thank you. You have learned some important topics so far, as we hope you had a good time learning with us. Browse through our online library for more content on the MSBTE website. Thank you. Stay connected. Happy learning.